Hey everybody, today we'll be learning about the text-to-speech with Elevan Labs, and we will be using requests with Python. If you want to learn about the Python package itself, I have a video for that at the top right showing in the banner right now. If you want to check that out, just go ahead and go to that video. If not, let's jump right into using requests. So to start off, we're going to do our imports. So obviously we want to import requests, and I'm going to import OS and from .env, I'm going to import load env because the way I have my API token set up is inside of this env file. I've made environment variables and I have to load them in from .env in order to use them. It's a safe way to store your access tokens rather than putting them in plain text where they are vulnerable. So now from the GitHub, I'm going to just go ahead and paste these variables so we don't waste any time. With the chunk size 1024, we will get to what this is for later on. XI key is OS key and env because we're grabbing from that env file. Voice ID is equal to voice ID for a specific voice we want to use. Now, let me show you how to get that voice ID. So in the text-to-speech docs, you will want to scroll down to voices right here, hit Voice Lab. And if you haven't already made an account, you'll want to do so now because you will need that if you are going to use this at all, actually. So to sign up for an account, get your API key in the profile settings, put it into your code, and now you can use the Voice Lab where you could go find a voice, you could design a voice, check out some preset voices in the voice library, choose to use it. It will show up here in the Voice Lab, and you can click the ID and it will copy to your clipboard. Then you can go paste it into your code. And the URL is also on the Elevan Labs documentation, and it is a formatted string where we insert the voice ID to the very end of it. So now that we've set our variables, we can go ahead and set our headers. I've copied this from the GitHub and I'll just go over what it is. So accept needs to be audio MPEG if you're going to be making MP3 files, and I believe it also works for MP4. The content type is nearly always going to be application JSON, and XI API key is obviously going to be set to our XI key that we retrieved earlier. Now we could set our data variable, which is another dictionary for our JSON response. Set the text to whatever you would like the bot to say, because this is going to be the text generated by the AI. Model ID can be set to whatever model we're going to use. Free tier, I believe, only has access to monolingual v1, but if you begin paying for it, you will have other options. So this is just whatever model you're using. The voice settings, first we have stability, and this is a ratio of how stable versus how emotional your bot sounds. I set it at 0.5, but say you set 0.1. This is a very emotional bot versus 0.9. This is a very monotone bot that is super stable in its intonation. And similarity boost, I'll demonstrate what that does whenever we start testing the bot. Now we can actually create a response. Response equals request.post with URL set, and then we could say JSON equals data, and that would be the body of our JSON request. And then we can say headers equals headers. Super simple to set up. This is essentially making a post request to the API. And if you don't know about requests, we run it down for you. We got two main types of requests. We have get and post. Get retrieves a value from the server. Post either changes or creates something on the server, and we get the value returned to us. Either way, there's a value returned. It's just there's differences that you need to be aware of when working with an API. The next chunk of code, I don't want to waste time, so I'm going to copy paste from the GitHub. We have with open MP3 with permissions as F, and if you're familiar with the basics of Python, you will know that this is creating an MP3 file. Now, the inside here is not quite familiar to anybody. For chunk in response outer content, with chunk size 1024, that's where this comes in. So we're finding a chunk in the iteration of content, what this is doing is basically finding the content of the audio stream. It's a little complicated. If you've worked with audio, you'll understand that chunks are returned, and it's essentially what audio is made of. So we're finding each little piece of the audio, and if the chunk has a value, we're writing it into our MP3. So this will create a pretty clean sound. So now we can actually test the bot out. We can run it, and it will generate over here output MP3, and you can hear how our bot sounds.
Like and subscribe if you're enjoying this.
And you see it's pretty stable on the voice. We can change to 2 and hear it be less stable. It'll regenerate our MP3.
Like and subscribe if you're enjoying this.
You see the emotion was a little out of whack there. But if we say 9, then it's incredibly stable monotone voice.
Like and subscribe if you're enjoying this.
You see the tone was it didn't waver much, you know. So that is what stability does. We'll set that back to 5. And similarity boost, let me demonstrate that.
Like and subscribe if you're enjoying this.
You see the volume of his voice really changes. I'm not entirely familiar with what similarity boost does, to be honest. I just kind of experimented and figured out that it sounds like
and subscribe if you're enjoying this.
That the chunks are less similar whenever. So what I assume this does is it raises and lowers the volume at different levels based on this ratio, or spaces out the words. It does one of the two, because the results have varied greatly. So I'm not entirely sure what this is for. It could probably even be excluded from our request. But yeah, that is the basics of using talk-to-speech with Elevan Labs through requests. If you enjoyed this video, be sure to like and subscribe, as this really helps the channel grow and provides support so that I can continue to make videos like this. Until next time, keep on coding.